There we go.
I'm just getting over my...
Alright, welcome to the review session. Today, we're going to start off with limiting reactant, then do excess reactant, then go on to percent yield. That includes the actual yield, theoretical yield, the empirical formula after that, and then for the honors, the only thing that separates the general from the honors in this test is the combustion analysis. So after you get to the empirical formula, if you're in general, you can leave. You don't have to watch the end of it either. Okay? The honors kids, you can stick around for that. Ready? Let's do this. So to start off, we get the limiting reactant. In any kind of a problem, let's just say that you have a regular old problem like this, like C2H6 plus O2, and that gives you CO2 plus H2O. Let's use this as our main equation for today. First of all, how do we balance this? We've got to practice balancing first before we get anywhere, which is kind of like, it's just implied with all of this. You've got to balance the equation first. So how do we balance this? First thing we do is we look at the most complicated element, or the most complicated molecule. In this case, it's right over here. We got C2H6. Let's look at the C's. There's two of them over on this side. There's one over here, so I'm going to put a 2 in front of that. So now the C's are balanced. It's all good. Now let's look at the H's. There's 6 on this side, and there's 3 on this side, so I'm going to multiply this by 3. Now the H's are balanced. We're all good. Now let's look at the O's. The O's over here, there's 2 on this side, there's 4 right here, and there's 3 over there, so 4 plus 3 is 7. That's kind of weird. So there's 7 on that side, and there's only 2 on this side, so there's no way you can possibly get just a pure 7 on this side. So what you have to do is multiply this by 3.5, knowing that you're going to multiply all of these by a factor of 2. Okay, so this is one of the more complicated kind of balancing questions that I put up on here for a reason. Okay, you following me so far? Okay, good. So now, if everything's multiplied by 2, that means that, it's a different color. This is now 2, this is now, as you can see, it's going to be 7. This is going to be 7. This is going to be 4. And this is going to be 6. So now it's all balanced. And you can double check if you want to make sure all of the elements are all balanced out, but they are right now. You can take away this 2 on the inside. Now it's totally balanced. Let's stop using this brown. And now let's say that in the problem like this, I first give you this to balance. The next part I'm going to say, suppose I start off with, I don't know, 76 grams of C2H6, and, I don't know, let's do 159 grams of O2. So we got those two quantities. Figure out what the limiting reactant is. Which one of these reactants limits the reaction from going forward? Find the limiting reactant. That's your question. Figure out what that is. To do this, you start off by just seeing first how many moles of the C2H6 there are. So let's try it. Start off with 76 grams of C2H6. C2H6. To convert into moles, you're going to be using 1 mole of that C2H6. And you divide it by the molar mass. So it's going to be 2 times 12.011 plus 6 times 1.0079. This is going to be in grams. That'll get you into the units of moles of C2H6. Follow so far? Okay. Next, you're going to convert those moles of C2H6 into moles of product. We can pick either one of these products. Which one do you want to pick? CO2 or H2O? CO2. I got both.
CO2.
Pretty adamant.
H2O is a better
CO2.
number. It's close to being 10, therefore a better number.
I remember the number H2O. The molar mass, so I'll just do that, okay? It's okay, Jill. So I'm going to do H2O. I'm just going to turn it into that. So to do that, I'm going to see, okay, so there's 6 H2Os. So I'm going to say 6 mole of H2O. every 2 of the 2 moles of the C2H6. So now I've got moles, whatever this answer is going to be in terms of moles of H2O. Okay? So that's just for one reactant. And you can go through these numbers right here. And I'd like somebody to try this while we go through the next one. So someone can put that in your calculator and tell me what you get. Right now I'm going to go through the other reactant. I'm going to do the oxygen, 159. O2. I'm going to set it up exactly the same way, except now I'm going to use oxygen. I'm going to convert oxygen into H2O. So 1 mole of oxygen is going to be 15.999 times 2 grams. Now I'm going to turn the mole of oxygen into moles of H2O. So we still have 6 moles of H2O. And how many oxygen? We get 7. 7. Now, you might be wondering, why does he put the H2O on top and why does he put that on the bottom? The reason I do that is because I want to cancel out our reactant and I want to turn it into the units of the product. So this is always going to cancel out the bottom, and the top is going to be what your answer is going to be in. So this is going to be still in moles of H2O. So Andrew, I heard you get an answer for the top. What was that?
7.582 459
459. Okay. I'll just leave it right there. That's fine. Okay. What's the bottom one? Does anybody know what that one is?
I got 4.25 9194.
Let's just leave it right there. Okay. So you can see which one's going to be giving you more product, which one's going to be giving you less product. This oxygen is going to be limiting your reaction. So this is our limiting reactant. It's not. You won't get full points if you circle this. If you circle this, this will not be the correct answer. That's telling me that you've got less product over here. So that's not telling me what the limiting reactant is. This is your limiting reactant. This is the reactant that limits the reaction. So if you just circle that, that tells me that this is a less product. It doesn't say anything about the reactant. That doesn't tell me that you understand what's going on here. The limiting reactant is this guy over here, 159 grams of O2. Right? So that's that problem. Limiting reactant problems, they're kind of the basis of any kind of calculation that we do. So our answer is over there. Our answer tells us that this is the limiting reactant. The final answer is this is the limiting reactant. You have to show all your work to get full credit. Okay? You can't just circle one and say, oh, that one's it, Mr. Sands. Okay? Alright, so we got that taken care of, limiting reactant. Now, let's make this problem more complicated. Right? Let's make this problem more complicated. And let's try to find the excess, find the amount of excess reactant remaining. Okay? The amount of excess reactant remaining. This is kind of the trickiest part. Okay, so we're going to be using this right here. This is going to be an important number. I'm going to erase everything else but this. Okay, so this is our limiting reactant. This is the product that we get with our limiting reactant right here. So in other words, that's the maximum amount of product we can get starting with this and this. That's the maximum amount of product we can get, starting with this and with this. Okay? So now I want to calculate how much of this is extra. Okay? Because we've used all of this up in our reaction, and that's what our product is. But I want to count how much of this is extra. So how many grams of this is left over? That's our excess reagent. Kind of with me? Sort of with me? Make sense? Okay. Alright. So now I'm going to take the moles of H2O and I'm going to do something kind of weird. I'm going to take those moles and I'm going to turn them into moles of C2H6. Okay. I'm going to do that because it takes the number of these molecules and it turns it into the number of these molecules. We want to figure out how much of these have reacted when you get this much product. Okay? So we want to see how much of this stuff has actually reacted first. And then we can subtract that from our total amount. Let's see if it makes sense to you when we get through. So I'm going to take that 4.2, I'm going to use as many sig figs as I can. Moles of H2O. I'm going to convert that back into our non-limiting product, our excess product, our excess reactant right here. And I'm going to say, okay, now I've got this many moles of H2O. I'm going to turn that back into this C2H6. So I'm going to put H2O on the bottom. We've got 6 H2Os, 6 moles of H2O. And for C2H6, there's 2 of them. 2 moles of C2H6. Okay? And at that point, we're going to have moles of C2H6. These will cancel out. Okay, so that would be the moles of C2H6 that have reacted when you get this much of the product. Okay, now from there, we're going to see how many grams that is. So that's the moles of C2H6, but we're going to turn that back into grams. To do that, you multiply by its molar mass. So 1 mole of C2H6, and that weighs 2 times 12.11 plus 6 times 1.0079, whatever grams that is. It's going to cross out the moles of C2H6, and it's going to be a certain amount. Andrew, you got that?
I'm actually...
At all.
Oh, okay, I get it.
So watch it again and again, replay it, replay it, replay it. Okay? Because this part is the tricky part.
Molar mass of
The C2H6. This is the trickiest part. As soon as you get an answer here, I'm going to walk back through it, okay? Got an answer? What's wrong with the same answer? 4.259194 times this, 2 over 6, same thing as divided by 3, times this.
Times 2 point, blah, blah, blah.
Times, it's going to be parentheses 2 times this, plus, in parentheses 6 times this.
Okay. 42.690.6935.
What'd you get?